So we're familiar with the unit circle. We've done this in trigonometry before. X squared plus y squared equals 1, or written parametrically, x equals cos theta, y equals sine theta. And we can develop our graphs from the unit circle. So this particular point here, I'm saying this is an angle of 30 degrees or pi on 6, this first line out to here. So this particular point here, we'll have the coordinates, whatever cos of pi on 6, sine of pi on 6 is. That's what the coordinates at that point will be. Now, cos of pi on 6 is equal to root 3 on 2, or about 0.866. And sine of pi on 6 is about a half. So I'm going to have a look at how the x values change. As we rotate around the circle anti-clockwise, I'm going to look at how the x values change for each of the points on here as we move around. So at 0, out here, the x value, when the angle is 0, the x value is actually 1 and the y value is 0. So I'll go up here and plot that point. Next, when I get round to pi on 6, I get up to about 0.866 is this point here, because pi on 6 is 0.866 across, right? 0.866. So I'm going to plot that there, 0.866 for pi on 6. That's there, sorry. And for 2 pi on 6, which is pi on 3, which is this one up here, then down here, cos is equal to about 0.5. The x value is about 0.5. And then when I get around to 90 degrees, which is 3 pi on 6, the x value of all coordinates on here would be 0. So you can see that it's heading down like that. At 4 pi on 6, which is 2 pi on 3, so we come around to here, this point here, cos is at about minus 0.5. It's about minus a halfway across. When I only care about the x coordinate of this point, I only care about how far it is from the y-axis. So that's about there. When I get round to here, then I'm all the way out here at minus 0.866. And when I get all the way out to minus 1 here, that's minus 1 comma 0, but the x coordinate is minus 1. So I'm plotting what's happening to the x value as time goes on. As I rotate around, the x coordinate is doing this. The x coordinate will keep, as I keep rotating around, it'll keep moving through the same, and it'll look like a wave, and that's the cosine function there. So I'm just going to write y equals cos theta, where theta is the amount of turning in the anti-clockwise direction. Now, what about the sine wave? Well, then, instead of worrying about going just acrossways, or what's the x coordinate of each point, we're going to worry about what's the y coordinate of each point when we do the sine wave. So I'll do that in green. The y coordinate of each point. Well, when it's pi on 6, the y coordinate of pi on 6 is a half, because sine of pi on 6 is a half. Because we know every point is cos theta, sine theta. So at pi on 6, we're at a half. Of course, when you start off out here at 0 angle, there's no height out at that point. There's no y coordinate, well, 0. So that's where you are there. At pi on 3, how high up are you at pi on 3? What is that height? Well, that height is all the way up there. That height is 0.866, all the way up there, right? Because it's not far from 1. Whereas when you were here at pi on 6, your height was 0.5. And then you get up to 1, when the angle is 90 degrees, your y-coordinate is 1. And then you head back down again. Your height here is 0.866. Then your height here, the height is only up at 0.5. I'm only worried about the y-coordinate. And then here, the height is at 0. And as you move through, you just go there, 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 and we'll be up at there again. And you can see that we've developed the sine wave. And they're very similar. They're out of phase just by an amount. By what amount? Well, if I wanted the black one to move across and land on the green one, for example, I'd have to move by pi on 2. Or I could move pi on 2, the green one back by pi on 2 and land it on the black one. So they're the same curve, just at different phases. So there's a cosine wave and there's a sine wave, and they're like a cyclical motion, because you can see with this green one that we get back to the same point that we started at and we head off again. Or with the black one, we start at 1, we get up to 1 here and we head off again. So it's like a cyclical motion. It's a harmonic motion. It's a wave, it's cyclical, it's harmonic. And so something to do with motion in a circle will be to do with harmonics. When you start to peel off, either looking at it only from a horizontal or only from a vertical perspective.